everyone, my name is Erin Canning and I am the Ontology Systems Analyst at Lynx. Today I'm going to give a short talk on the use of CIDOC-CRM by Lynx and the reception of the solution by the researchers with whom we work. I'm going to start by telling you about Lynx and the context for this work, and then focus on working with researchers in the data mapping and conversion stages of the project. This talk will be as much about working with the people involved as with their data. I will focus on the steps we've taken to educate and engage researchers and discuss how this has led to an enthusiastic reception of a complex solution. The researchers and data holders that have had their data mapped to CIDOC-CRM at Lynx have expressed excitement about the new level of detail they can bring to their data, as well as about the affordances of the structure for supporting how they conceptualize their data. So to start out with, I'm just going to tell you a little bit about Lynx. Lynx is a 3-year project funded by the Canada Foundation for Innovation that seeks to convert researcher datasets into an organized, interconnected, machine-processable set of resources for cultural research. Lynx is bringing together datasets created by researchers working in a diverse range of humanities and social science disciplines, along with institutional datasets from museum and library partners. And it's converting the source data into linked data, making it available for human exploration as well as machine processing. So Lynx data focuses on research datasets. This means we're taking datasets created by those humanities and social science researchers from across Canada and converting the contents of those datasets into linked data. Lynx isn't representing the metadata about their sources, but the data held in them. Lynx works with numerous researchers and across diverse domains and multiple epistemologies. Datasets range from metadata on art or publications through to information about people from diverse historical periods, representations of manuscript variants, second-wave feminist magazine advertisements, literary influences, and more. And they represent complex domain-specific relationships driven by research questions. At inception, 47 researchers joined the Lynx project with 36 datasets among them. These datasets are quite different from each other and as a whole are frequently different in nature to institutional datasets. They reflect long periods of engagement by a specific researcher or research team and represent the researcher's theoretical foundations and worldviews as well as domain data. They often come from bespoke databases built specifically with the project in mind, or other more ad hoc data collection and management processes developed over time to suit the researcher's data use practices and research methods. As a result of the context in which Lynx works, as well as the theoretical foundations of the project itself, Lynx data structures must be able to represent multiple diverse ways of knowing and to enable various ways of incorporating contextual data. As we address specificity in each research dataset, we're simultaneously working to balance interoperability as achieved through a level of generalization with contextual and domain-specific requirements. Our approach to ontology adoption and use centers on intersectionality, multiplicity, and difference. The question of what meaning the structures being used will bring to the data is as important as what meaning is introduced as a result of linking the data together. And the project has built this premise into its decision-making and implementation processes. In order to bring all of this data together into a shared information environment, Lynx will be using CIDOC-CRM as a core ontology. The CRM was chosen not just because of its technical and domain fit, but in accordance with policies regarding the selection of ontologies drafted at the very beginning of the project. So at the start of the project, the Lynx team produced the first draft of the Lynx Ontologies Adoption and Development Policy, which governs the project's approach to ontology selection and implementation. This was done before any decisions regarding ontologies were made, as the team felt it was important to first outline the values and criteria against which potential ontological solutions would be assessed. The purpose of the Ontologies Adoption and Development Policy is to articulate key project values and lay out how the Lynx team plans to operate within the linked data space. Lynx, by design, includes researchers whose datasets embed contestations of mainstream or hegemonic understandings of history and of how knowledge works, and which often involve boundary objects. This diversity of representation was a criterion at the initial project selection stage, as grappling with multifaceted and marginalized ways of knowing through linked data was a major goal of Lynx from the outset. In order to serve this data in a way that does both the data and the researchers using it justice, the Lynx team needed to ensure that selected ontologies were capable of representing non-hegemonic epistemologies, as well as of describing alternative knowledge representations. The links team has adopted a collaborative and iterative process of ontology selection and development involving researchers and members of the links community. So guided by this policy document, ontologies are evaluated and selected in collaboration with links user communities. All ontology decisions go through the ontology working group before being used in the project. And this is a group that's made up of researchers from across links and is bolstered by additional domain experts as required. This process ensures that decisions about ontologies that affect specific domains are made in consultation with researchers from those domains. And the first question that was tackled by this group is that of CIDOC-CRM. CIDOC-CRM fits links requirements due to the domain it covers, the event-centric approach, and the relationship that it holds to vocabularies as external to the ontology itself. Adopting CIDOC-CRM allows links to accommodate a wide variety of data domains and sources, which is an essential requirement. Additionally, this kind of structure, one that positions actions at the core of data creation, curation, and interpretation processes, highlights the contextual nature of information, as CIDOC-CRM recognizes the dependence of data on human activities of meaning-making. CIDOC-CRM also allows links to represent general concepts that are shared across datasets and domains, even when they're called different things, while still allowing for the description of each element involved in each dataset in as much detail as the researchers require. This allows links to achieve a high level of interoperability without compromising on domain-specific description. In addition to the practical and technical affordances, adopting CIDOC-CRM as a core ontology also means that links is positioning data as fundamentally being the outcome of activities, things that people have done and the results and outcomes of their actions, as opposed to facets of an entity. Data is never a neutral, indisputable aspect of something. It's made with intent and reason by people at moments in time and in particular places, and this context is essential for understanding the data. Because CIDOC-CRM is able to support this kind of view, along with its other affordances, it helps links to work towards our project goals of highlighting the relational and contextual nature of the data that our researchers seek to represent. So I want to talk about working with researchers and data holders because of the complexities of these relationships. At Links, we work with researchers as partners on the project, and we work with many researchers coming from diverse domains and theoretical backgrounds and perspectives. This raises some interesting questions to keep in mind, like what you can see on this slide, such as how can we help researchers to explore data in each other's data sets, and maybe even show how they think differently about shared entities by building this work in as part of our process of working with researchers throughout, not just through the converted data and user interface affordances. Questions such as these drive how we will work with researchers at Links. Today, I'm going to describe our data mapping and conversion workflow and then discuss some of the results of this approach. This workflow is an iterative process of meetings, mappings, and feedback. It has 6 main stages, although as you can see, it's not a straight progression through them, but an iterative process. The first stage in this process is to conduct a data intake interview with the researchers. This is the first point of contact between the Links team and the researcher in the process of ingesting their data. It's not the first point of interaction between the researcher and Links ever, as they've had to indicate their desire to work with us in order for us to schedule an interview with them in the first place, but it is effectively the first step in the onboarding workflow. As with any collaborative work, this starts with a process of conversation and understanding. In order to map the data, it's essential to understand the data, not only in how it's provided, but also how the researcher thinks about it and works with it. These interviews are an entry point for larger conversations about the data and projects. A series of questions provide a framework for the interview, but the conversation is semi-structured so as to explore facets of interest as they come up. Question prompts in these interviews are intended to get researchers thinking about their data in new ways, talking about their data set in detail, and situating their data with respect to other data sets, both within and beyond Links. The outcome of this stage is a clear understanding of the data set as viewed through the eyes of the researcher and access to a sample of the data or the data set as a whole. After the interview, we receive the researcher's data and do a preliminary analysis. We'll examine any documentation they're able to provide and dive into the data to see what all is in there. There are a number of questions that we ask when we do this, and we'll reach out to the researcher with questions if things come up that we can't figure out an answer to during this process of review. At the end of the review, we will identify a representative sample of data. So this means we'll pull out the minimum amount of data that represents the high majority, if not all, of the data in the data set. Another way to think about this is that we look for the most complete records to use as examples. With this representative sample, we then do a preliminary mapping and document this in order to bring it to the researchers for review. Mapping is the translation of one data structure to another according to systematic rules, and in this case, following the structure of the ontology we're using, CIDOC-CRM. This requires knowledge of both the datasets and the ontology and is part of the reason why stages 2 through 4 are iterative. As we get to know the data better, we are better able to represent the concepts held within them. We go back and forth between dataset analysis and preliminary mapping to make sure that what we are constructing properly represents the dataset as a whole, as well as the domain that the data comes from and the researcher's view of their data. Once the preliminary mapping is done, we also produce review artifacts documenting this in order to facilitate conversation with the researchers who are often not familiar with this kind of data work, and especially not with CIDOC-CRM, and I'll talk about those more in just a moment. Stage 4 is meeting again with the researchers to review the preliminary mapping. During this meeting, we focus on discussing not just the proposed changes to the data structure, but the changes to the meaning of the data that restructuring and alignment with links ontologies entails. The review meeting is an opportunity to talk about the different meaning that's brought to the data as it's described in different ways, and ideally to show researchers how linked data structures may be able to help them more clearly represent and articulate their data or the information required to get to the heart of their research questions. This meeting is a key moment for educating researchers about CIDOC-CRM, and ideally for getting them excited about the mapping and the solution. This is the first time that many researchers are going to be seeing their data in this way, so it's essential to make sure that they feel welcomed in and that they see their expertise reflected in the data mapping. So after that preliminary mapping, we have those bite-sized pieces of source data transformed into the structure we would like to use to ingest all of that data into links. This is something that we can review with the researchers during the stage 4, as it's not so big as to be overwhelming, and it gives them an idea of what their data would look like en masse. To facilitate this review, we prepare 3 artifacts: comparison data files showing the data before and after, a mapping spreadsheet to show how the concept is represented in the data before and after, and diagrams visualizing the contents of the mapping spreadsheets and data file. So here you can see an example of a comparison of this used during the review with one of the Link's research projects, the Yellow 90s personography. The first row describes the concept in plain language to ensure we have a shared understanding of it, in this case that there is a person who is born at a time and a place. The second row compares the original data structure to the mapped one. Here, the left-hand column shows the subject and 3 predicates used in the source data to describe birth date, birthplace, and a Wikidata URI representing a place that's less specific place of birth for that person. The right-hand column then shows this map to CIDOC-CRM, introducing the E67 birth event, as well as structuring the relationship between those birthplace and birthplace URI concepts from the source data. The final row is then a place to populate items for discussion, in this case confirming that the relationship between place concepts is one of P89 falls within. And here is an example of that same data, but represented visually. This helps to immediately highlight the additional detail and meaning introduced to the data through the application of the CIDOC-CRM ontology. We've kept the same table structure for ease of understanding. Having both the data snippets and the diagrams makes what's happening here, so this mapping of data, understandable through a couple of different methods for folks who prefer one way of understanding over another, and allows us to go back and forth between the visual representation and what the data actually looks like in order to make sure that the mapping solution being proposed is clear to the researcher. After the review meeting, we'll then go back and tweak any areas of the mapping that the researcher wasn't happy with and go back and forth with them with the results, either by email or in follow-up meetings, depending on the extent of the required changes. And so these 3 steps of analysis, mapping, and review are repeated as many times as required to come to a mapping that the researchers feel represents their data. It's very important that the researchers understand and hopefully get excited about the end result of this process, so we spend a good chunk of time making sure that we're communicating as clearly as we can some things that can get pretty complex. And then, once the mapping is signed off on, we move that from a manual one to a systematic technical one. So we use the X3ML toolkit to transform the data based on the rules defined during the mapping process. Lastly, we document the decisions that were made during the mapping and review process. The documentation then becomes a key asset for Link's team members, researchers, and other users. It tells researchers how their data is structured, tells users how to explore and query that data, and it tells links team members how the concepts present in the dataset have been mapped and represented. Then, when a concept that sounds the same shows up in a different dataset, we can suggest and test an already implemented solution for the new context. Using the same solutions for shared use cases and requirements increases interoperability between datasets, even when the vocabulary referenced by the different projects may be different. In this way, the links team is able to find paths to the greatest level of semantic alignment or interoperability between datasets as we possibly can, while maintaining space for representing essential differences. Additionally, although an existing solution may be proposed for a use case that appears the same, this too is up for discussion. If the solution that fits best for one dataset does not in fact work for a second, the new dataset will not be forced to use the existing pattern, and a fitter solution will be devised instead. This also helps us to start on some of those questions I referenced at the beginning of this section, of breaking down walls between silos and building networks between people as well as data. By proposing solutions developed in the context of one project to another, we're able to introduce different researchers to each other and how they're thinking about similar concepts in a shared domain. We're able to start doing that work of building and supporting networks between people before they're able to have the opportunity to do so through their data, and in this way, priming them for cross-collection exploration, discovery, and research. So a few moments of reflection on this process, our experiences with the researchers and their reception of CIDOC-CRM. During this process, we've taken the opportunity to really teach researchers about CIDOC-CRM and what it can do for them, as well as to proceed on the technical conversion goals of the project. Because of this focus on creating a network of people as well as data, we've focused our steps on educating researchers and making sure that they're comfortable and engaged throughout the data mapping and conversion process. This so far has led to an excellent reception of a complex solution. The researchers are excited to see their data in this new light and express feeling a level of comfort with the CRM classes and properties being used to represent their data. Researchers have been excited about both the new details they can bring to their data when it's structured this way, as well as the focus on how the CRM structure can be used to present their data in ways that align with their foundational theories and research viewpoints. Researchers seem genuinely engaged and excited at the prospect of both engaging with their data in this way and with the CIDOC-CRM as an ontology more broadly. I think this is in part because we framed our conversations with researchers about CIDOC-CRM in ways that are intended to give them reasons to care about the CRM and care about learning and using it beyond the limited scope of the links context. And in order to do this, we needed to show them why they should care right from the very beginning. Researchers need to see what this can do for them and in multiple ways. For this particular set of users, the researchers at Links, the technical connection of linked data isn't enough. The affordances of the semantic structure and the chosen ontology and what this data representation says about and with their data and subjects is just as important and valuable to these users. So my next thought is about shared concept representation, or namely the connections that can be forged in the people and data when different researchers represent shared domain concepts using the same classes and properties put together in the same way, and are able to explore each other's data because of these commonalities, using them as bridges from one data set to another. In Links, one particular case of this that I think is interesting is a pattern to represent identity elements, such as gender, religion, and other social classifications that came from the Orlando Women's Writing Project. This pattern, referred to as cultural forms, positions identity categories not as fixed classifications, but instead as contextually embedded, culturally produced, intersecting, and discursive. In other words, as starting points for investigation and understanding, and not immutable points of data about a person. It's represented in CIDOC-CRM by framing it as the identifications that have been made between a person and a label or term used to represent the identity concept. This allows us to say who asserted that connection and in what context. So if it was a person speaking about themselves or a biographer writing about them after their death, as well as to situate the term itself in the context, the time and the place in which it was used, and thus the meaning regarding identity that it may have been likely intended to convey. It's definitely a more complex representation than the usual approach recommended, but it is one that uses CIDOC-CRM to represent a complex concept with the level of nuance that's required by humanities researchers. After mapping this pattern from the original Orlando structure to CIDOC-CRM, the links team introduced additional incoming data sets to the representation to see if it matched how other researchers were thinking about the same idea, even if it was not how it was yet represented in their data. The uptake of this by incoming datasets beyond the Orlando project has shown how shared concept representation, as shown through data modeling, can build new connections between researchers and datasets. So as is evident from this case of Orlando and the cultural forms concept pattern, it's essential to attend to the changes in meaning brought to the data through the conversion process. This is not solely a technical process, but an interactive human and ideological one as well. The data is not only changing in format, but in times also in meaning, as it moves into a new data structure. The mapping and conversion of source data to CIDOC-CRM can bring new meaning to the data, as structure contributes to the meaning of the information it describes. This has proved beneficial for researchers, such as those from another links project, Archive, which focuses on late 20th century feminist journals, magazines, and other periodicals. This project is firmly grounded in feminist theory, such as attention to labor, the acts of people, especially when that labor is gendered, undervalued, or unseen. Following the first review meeting, the researchers on Archive spoke about how the event-based structure introduced to their data through the application of CIDOC-CRM echoes this foundational viewpoint, and how it's therefore able to represent Archive data in a way that's more closely aligned to how they already think and talk about their data. This insight also confirmed for us at Links the need for researchers to be able to see themselves in their ways of thinking in their data. A lot of Links researchers come from critical theory backgrounds, so feminist theory, queer theory, critical infrastructure, and so we're deeply aware of the non-neutrality of databases and other information organizing systems, even if they're not familiar with CIDOC-CRM. And I really like working with CIDOC-CRM for representing this kind of data, because as came up with Archive, there's that focus on people as absolutely central to the creation of any and all data. There's a core acknowledgement of the contextual nature of data and the inability to separate data from the events of its creation. I've previously talked and written about this as the focus on people and highlighting the roles that people take in making data, but the insights from Archive really moves the focus into that realm of feminist theory and attention to labor. So now to turn briefly to what comes next. Links is now halfway through its timeline, and so there's lots of work left to be done. For example, we are now returning to datasets ingested in the early phases of Links, so as to allow those datasets and their researchers to benefit from and adjust their mappings in light of the subsequent collaborative knowledge gained by working with other researchers who are later through the pipeline. This will increase overall interoperability between Links datasets, as well as bring in those researchers in new ways. We've only recently begun this work, and this is one of the immediate next steps for the project. And then, of course, there are many more datasets from even more varying domains to take in, which will be considered after this halfway review phase is complete. Secondly, we need to make sure that we have documentation available for different users. Even amongst research project teams, there are different needs. So we've identified 3 different levels of need based on how they interact with the data: technical documentation for the entirely technical colleagues, a mid-level technical kind of documentation for users such as research assistants who are working with lead researchers and working directly with the data, and then researcher-facing documentation. That's the least technical and aimed at supporting their conceptual work with their data. So far, we've really focused on that middle section, a level of documentation that includes technical details and ontology patterns as seen through the researcher-described concepts they represent. We need to both ensure the robustness of this documentation and expand efforts for all users. To that end, I'm excited to see the presentations on documentation at the CIDOC conference this year. And lastly, we need to continue the support we've given researchers through the phases I've presented today in order to make sure they're also able to work with their data post-conversion. This will be a combination of documentation that I mentioned, as well as technical tools and platforms and their related affordances. For example, Links is using ResearchSpace as its semantic data management platform, and we've started working with researchers in this platform in order to support their use of the system, with much more user testing to come. So to conclude, the Links team aims to embed project values that are themselves rooted in feminist theory and ways of working in the project's infrastructure, not just in the final product, but also in the processes that make up each stage of the work and the ways that we collaborate and work with others. We aim to lay bare the processes that led to the creation of the linked data that Links takes as its knowledge base, including the data modeling stages and the collaboration with researchers throughout this process, which has been the focus of my talk here today. Ultimately, developing information infrastructure means creating structures that give data meaning. No organization of knowledge exists without embedded worldviews. Information systems are developed by people with intent. They are designed to help their creators and users to tell specific stories with their data. The Links team is doing just that, building processes and infrastructure to help humanities researchers tell the stories they're interested in. I hope my presentation today has given you a bit of a view into how we work with researchers during the data mapping process in order to try to do just that using CIDOC-CRM. And that's the end. So thanks so much for listening to my talk. If you have questions or thoughts, I'd be more than happy to hear them. You can reach me online or by email. I'd love to hear from you. Thanks again.